Again. Okay, so we're going to do applications of exponential. You'll find a lot of science examples. Example 1, the most intense earthquake ever recorded was in Chile in May 1960 with a magnitude of 9.5. Given that the Richter scale m equals log of I over s, where m is the magnitude of the earthquake, I is the intensity of the vibrations of an earthquake, and s is the intensity of a standard earthquake, calculate how many times as intense as the Haiti earthquake was the Chile earthquake if Haiti experienced an earthquake with a magnitude of 7 in 2010. Does anybody remember the 2010 earthquake in Haiti? Yeah. Oh, there was lots of fundraising and stuff like that with it. Okay, so let's see what we know so far. All we know is we have a magnitude of 9.5 for the Chilean one, and we have a magnitude of 7.0 for the Haitian one. So let's write that out. The magnitude of the Chilean one, so I'm going to call it m sub c, is equal to log of I over s. We don't know what those are. The other thing we know is the magnitude of the Haitian one is equal to log of I over s. And that's all we know. And we need to know how much more intense it is. Does everybody understand that this intensity here is the intensity of the Chilean and this is the intensity of the Haitian? But S is actually the same for both. S is the standard earthquake. So that's this. And so the reason why this is a confusing question is there's so many unknowns and you're like, oh, I can't solve this because I don't have enough information. We actually do, because the S's will cancel and then we will get how much more intense it is. So for instance, if I say, I don't know, I have $5 in my pocket and Nico has $10 in her pocket, how much more does she have? How many times more does she have? 2. And how did you figure out 2? You divided. You took the more intense one, or the more money one, and divided by the less to get how much more. Okay, so remember that when we're doing how much more intense this is. So the first thing is we can't actually do much the way it is written in logs. So the first thing you have to remember when you have this question is you got to change it into exponential. So what's the base here? Yes. So 10. Oh, sorry, we do, before I go on, we do know the 9.5 and the, sorry, let's just put that in, I didn't do that. 9.5 and this is 7, right? 7. Okay, so now I'm going to change it into exponential. So 10 to the power 9.5 equals I, the intensity of the Chilean over S. And this one would be 10 to the power 7.0 is equal to the intensity of the Haitian over the standard. So does everybody see, again, remember what I said about the $10 versus $5 we divided? If we divided these two, do you see that this S's will actually cancel, and I will have the intensity of Chile divided by the intensity of the Haitian? Yes? And what would that be equal to? 10 to the power 2.5. You could say you could leave it like that, but honestly in a word problem that doesn't mean too much. So if we change that into an actual number, we can see how much more intense it was, just for reference here. So 10 to the power 2.5 is approximately 316 times greater. So then we would write a sentence. So therefore, the Chilean earthquake I don't know how to spell earthquake. Let's try that again. Earthquake is 316 times more intense than the Haitian earthquake. Okay, any questions there? Anyways, example 2. You've probably seen this one before in chemistry class, right? Yeah, the pH is equal to the negative log of the hydrogen atom. So if a pH is 6.2, how do you find the concentration? So the pH is 6.2, so you plug it into the pH is equal to negative log of your hydrogen. So, and your chemistry teacher probably told you to punch this in and you had no idea why you were doing this. So the first thing you have to do in order to change this to exponential is you need to move the negative over to the other side. So he probably told you, or she, you need to make it a negative or something like that. I don't know. Do you remember this? So negative 6.2 equals log of the hydrogen atom. Yes? And then now we're going to change it into the exponential. So 10 to the power negative 6.2 is equal to the hydrogen atom concentration. And if I punch this into my calculator, 10 to the power negative 6.2, you get a scientific notation, which I think you guys all know what to do. Make sure you do 3 decimal places then. So it's 6.3095 times 10 to the power negative 7. And I think that's moles per liter, right? Yes? Is that correct? Moles per liter? The growth of the internet can be measured by the number of computers offering information. They're called hosts. In 1995, there were 4.8 million hosts. If the number of hosts n million at any time t years after 1995 grows exponentially by 59%, calculate the following. The equation that models the number of million hosts n at any time t years after 1995 is n equals 4.8 times 1.59 to the power t. So it's not too bad. If you want to find how many million would be in 2010, what are we trying to find? N. And what is my t? 15 years later? Yes? Does everybody know how to punch that in? So this would be on the calculator part of the test, right? And it says to the nearest million, right? So this would be 5,037 million. Does everybody see that is the units? Make sure on these word problems that you put the units there. It says here, in which year did the number of hosts reach 1 billion? Would this be factual? So what would I do this time? You put 1 billion in for n, but what would 1 billion actually be? Huh? 1,000 million? Has everybody got that? Yeah? Because that's an extra 3 zeros to the million. So 4.8, 1.59 to the power t. How am I going to solve for t? Yes, the biggest mistake people make is they leave the 4.8 there and then they log both sides and then forget that this 4.8 is attached to this. So I would get rid of the 4.8 because it has nothing to do with the exponent. So 1,000 probably divided by 4.8 does not divide nicely, no. So I'm just going to leave this as 1,000 divided by 4.8 because we're not supposed to round until the final answer. Okay, so does everybody see how to get a t by itself? We need to log both sides, yeah? So log of 1,000 divided by 4.8 equals t log of 1.59. Is it okay that I skipped a step? It's not okay? Okay. So then t is going to be log of 1,000 divided by 4.8 divided by log of 1.59. So let's see how many years later it would be. So log. So 11.5133 years. So which year though? So you could say about 12 years later after that, but what year would that be? The first year was 1995, yes? Yeah, so therefore around 2007 there would be 1 billion hosts. But does that seem factual? I would say not, and why would you say not? I'm just thinking 2007, most people had cell phones then, right? So whenever the cell phones came into play, I think that exploded the number of hosts, right? I don't know, that's what I'm thinking. You know, because remember the definition they said is of a host was, yeah, so a phone would be that. So I'm thinking once phones got to, you know, do data, that would have changed, like that whole thing would have changed for sure. Okay, compound interest. We learned this in grade 12, grade 11 essentials actually. Yeah. However, we don't do the log stuff to solve for t. So A is the total amount. I'm going to say after t time. I'm going to add that in there. So P is the principal, and it is spelt like a principal in the school, and this is the amount invested. And if it's a loan, it's the amount loaned. R is the interest rate, and the thing that you have to know about the interest rate is you need to change the percent to a decimal in the formula. And how do we do that? Huh? How do we change a percent to a decimal? We just move the decimal place twice, yeah, to the left. It's as easy as that. N is the number of compounds per year. So if I say annual, what would N be equal to? Annual. How many compounds per year would that be? Yes, 1. Monthly, what would N be? If it was compounded monthly, how many times a year would that be compounded? 12, yeah. Let's say biweekly. What would biweekly be? I hear every 2 weeks. It's 26, yeah. Because there's 52 weeks in a year, yeah. And I guess daily might be 1. Daily N is 365, although you might argue blah, 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 but that's what they use, 365. Biweekly. Okay. T is the time in years. So if they give you the time in months, you need to convert it to years. Okay. So a $5,000 investment earns interest at a rate of 8.4%. What is it worth after 10 years if it's compounded monthly? How much interest was earned? So watch, when you figure out A, That's the total amount. That's the amount with the interest, right? So does everybody see we're trying to find A? $5,000 is the what? That's how much I'm investing. The principal, what's 8.4%? And the rate I need to change to a decimal. So what is that? Yeah, 0.084. 10 years, that would be my T. And compounded monthly, that would mean N equals 12. Does everybody see that? Okay, so now we're going to plug it into the formula. So 5,000, 1 plus 0.084 divided by 12 to the power 12 times 10. I know a lot of people like writing 12 times 10 and then they try to do it in their calculator. Just do the mental math. What's 12 times 10? 120. So if you want, I'll go N times T is 12 times 10 equals 120. Okay, so you should be able to punch this into your calculator in one fell swoop here. And remember, this is money, and although you don't get pennies back in the electronic world, you still have to the nearest penny. So this would be $11,547.99. So then what would my interest be? $6,547.99. Does that make sense to you? Anything earned past your $5,000 initial investment would be interest. Yeah? They like asking the next question. How long will an investment take to triple itself if it's compounded monthly at a rate of 6%? So they don't give you the amount. They just want to know, for whatever amount I invest, how long will it take to triple? So how much do you want to invest? You can invest $1. You can invest 1,000. You could also invest X. Yes? Let X equal amount invested. It's compounded monthly, so that means N equals 12. The rate is 6%, so that means my R is 0.06, yes? So how much would my investment be if it was tripled? 3x. So 3x would equal x 1 plus 0.06 divided by 12 to the power 12t. Does everybody see where I got that from? What do I have to do first here? Divide by x. Now, normally I would say you can't divide by x, but x is an amount that I'm investing and it's not 0, so I know it's not going to be dividing by 0. So does everybody see if I divide by x, these will cancel? So that's why it doesn't matter how much you invest. If you invest $1 or 1,000 and it becomes 3,000 or $3, once you divide it, you'll get 3 equals 1 plus 0.06 divided by 12 to the power 12t. Does everybody see that? So what do I do next? Yeah, I would log both sides. I might see if this is nice to add together, which I think it is. 0.0, like 1.005. So I'm going to go up here. So 3 equals 1.005 to the power 12t. Now I'm going to log both sides. If you have to round, do not round. So just leave it the way it is, right? Okay, so log of 3 equals 12t log of 1.005. So what is t going to equal? Yeah, log 3 divided by 12 log 1.005. Be very careful when you punch that in. Don't need brackets on the bottom. $18.3559, and that would be years because T is years. Does everybody remember that? So this time they're asking you for P, right? They're giving you A, compounded annually, N is 1. 6% is 0.06 per R, and 7 years is your T. So you don't really need to divide by 1, but I was just showing that that's what it is. So P would be 5,000 divided by 1.06 to the power 7. So approximately $3,325.29. Is that what you got? Okay, so I hope when you get an answer that the answer makes sense, that it should be less, right? So if you get an answer that it's more, then you know you did something wrong. Okay, so anybody that, some of your parents might do this. Does anybody know if their parents do RESPs for you? Yes, and do they, oh, well anyways, monthly RESPs? Okay. If your brother's already in university, he's probably withdrawing the RESPs. I'm talking about, you know, your parents investing, say, $200 a month for you for when you get to university to use, right? So, okay, so this would be the formula. And if you're curious, you can figure this out on your own. If your parents are, say, putting away $200 a month from when you were born to when you turn 18, how much money you'll actually get if the market was a certain percent. Now, 6% is pretty high right now, so you could probably put it down to about 4% if you wanted to do your own. But anyways, let's do this question. Given the formula for future value, and by the way, this formula, future value, the actuaries always use to figure out future value. So it's not like it's really that complicated. They do get some complicated formulas, but anyways, future value is equal to R 1 plus I to the power N minus 1 over I, where R is the regular investment amount, I is the interest rate per compounding period. So this is different. I is the interest rate per compounding period. So they're actually, I is actually equal to R divided by N, because it's the interest rate per compound period. So just so you know, N is the number of investments. So this is actually the number, I shouldn't write it as N because this N actually means something else. This is the number of compounds, right? Whereas N is the number of investments in this formula. Determine how many monthly investments of $200 would have to be made into an account that pays 6% annual interest compounded monthly for a future value of $100,000. So we need to have $100,000. R is the regular payment, so that's our $200. You got to watch all these brackets now. So bracket 1 plus. Now, does everybody see this is 6% compounded monthly? So what is my I going to be? 0.06 divided by 12. Does everybody realize that? I think that's the mistake that most people make. If they don't do enough of these questions, they don't realize they need to do that because they think it's like the compound interest question. So you get 0.005. Anybody validate that? So then it's 0.005. That's in those kind of brackets to the power N. N is the number of investments. Do we know? No, that's what we're trying to find because we're trying to determine the number of monthly investments. So we're trying to solve for N. Minus 1, square bracket, divided by 0.005. Does everybody see what we're trying to do here? Okay, so what would we have to get rid of first now? Yeah, we can get rid of this in one fell swoop, right? This goes up, that goes down, right? So 100,000 times 0.005 divided by 200. So I get 2.5 equals 1.005 to the power n minus 1. Yes? So what can I do next? I can add 1, so I get 3.5 equals 1.005 to the power n. I would log both sides. So log of 3.5 equals n log 1.005. So that means n is log of 3.5 divided by log of 1.005. And so it's approximately 251.1784. What does that mean? What did I just solve for? Huh? Yeah, so this would represent 251. Now, I would actually need more than 251 investments, right, to make 100,000. So this is where the gray area, do you say 251 or 252? Because really it's on the next payment that you actually get over. So you could say, oh, part way between. But let's just say, therefore, 252 investments. No, they would give you a little bit of leeway between 250. I would say when you calculate it, give the 3 decimals there, but then when you state it, they would accept either 251 or 252. 251 in monthly investments. There you go. So this time, this is the loan formula. So going back to the other formula, when you have time, figure out how much you're going to make by the time you're 18 if your parents were to give $200 investments. So the loan formula is for borrowing money, say, to buy a car, to buy, Okay, so R is the regular payment amount, I is the interest rate for compounding period, N is the number of payments. How many monthly payments of $300 would have to be made to pay off a loan of $15,000 that charges 6% annual interest compounded monthly? So what do we have to do here? 0.06 divided by 12, you probably know what that is already because we've done it enough times. 0.005, yeah? Okay, so $15,000 is the present value. Does that make sense, the difference between present value and future value? Future value is how much it's going to be worth in the future. $15,000 is present value, meaning the bank is going to give you $15,000 right now to buy that, whatever you're buying. I assume a car or something because it wouldn't be a house. $300, 1 minus 1 plus 0.005 to the power negative n, yes, divided by 0.005. Okay, so does everybody see? I'm going to do that little trickaroo again. That goes down, that goes up. Yes? I'm out of room. Did I give you enough room? Okay, so I don't know why I didn't give myself enough room. 15,000 times 0.005 divided by 300 is 0.25. Is that what you got? So 0.25 equals 1 subtract 1.005 to the power negative n. What would I have to do first? Get rid of the 1. So then I get negative 0.75 equals negative 1.005 to the power negative n. Then what would I do? Get rid of the negatives. So I'm going to make those both positive. Then what am I going to do? Log it. Log of 0.75 equals negative n log 1.005. And the reason why it's negative n is because when you divide right now, you'll get a negative answer and then it'll switch the sign, right? So n is going to be log of 0.75 divided by negative log of 1.005. You can forget about the negative and then just put it back in with your answer, if that makes sense to you. So if you type in log 0.75 divided by log 1.005, you'll get a negative answer, and then you just switch the sign because of the negative, right? So 57.6801. So what does that mean? Approximately 58 payments. So that would be over almost 6 years, right? Almost 6 years? Almost 5 years. What am I saying? Almost 5 years. 5 times 12 is 60. This is 58 payments, right? Yeah. Okay, the formula A equals P e to the power RT, also written as y sub t equals y sub y naught. Why not? Have you seen that in physics? With a sub-zero, that's for initial and, yeah, some people said yeah. E to the power kt works for all exponential problems. This is known as the law of population growth or the law of natural decay. The final amount is A after time t. P is the original amount. T is the time after time elapsed. It doesn't give you a unit. And R is the rate of growth. So the rate of growth will tell you what the T is actually in. A radioactive substance is decaying. The initial amount is 10 grams and 8 grams remain after 5 years. Find the decay. Sorry, I call it the PERT formula. Do you understand why it's the PERT formula? Because it spells PERT. Yeah. A equals P e to the power RT. So the amount after 10 years would be 8. The initial amount is 10. E is not a variable. E stands for what? Yeah, 2.7, blah, blah, blah. E to the power R, I don't know, but I do know it's 5 years, so it's going to be 5R. So what did we learn when I introduced E on Friday? When I log both sides, I am not going to be using LOG. I'm going to be using LN because that will simplify things. So before I do that, though, I need to get rid of the 10. So if I divide by 10, I get 0.8 equals e to the power of 5r. Now I'm going to ln both sides. ln of 0.8 equals, do I need to write ln on this side? Am I good? 5r. Does everybody remember why that happens? So r is ln 0.8 divided by 5. Make sure you close your brackets. So you get negative 0.04462 blah, blah, blah. And that would be, I guess it would be grams per year, but that doesn't make sense. So it's the rate. Does that make sense why it's negative? It's decaying, yeah. So, okay. I would actually keep this into my calculator and store it in alpha A. So we have an actual, store this answer in alpha A, so it's an exact value. So estimate the amount after 10 years. You go store alpha A, where it says STO. Okay, so estimate the amount after 10 years. So T is 10. I don't know what A is this time. But I do know that the initial amount was 10 grams, right? Okay, now I do write this, but be very cautious. These brackets do not mean brackets, they mean multiplication. Okay, so watch when you type that all in. And again, I would use the alpha A for this one. Alpha A, store. Okay, so 10 times E to the power. On your graphing calculator, the e to the power x will automatically put e to the power whatever. So then that's to the power alpha A times 10. So if you use the exact value, actually get 6.4 grams exactly. If you don't, it's very noticeable that you rounded before the final answer, because you will get a big long decimal. Do you understand? Okay, what is the half-life of this substance? Remembering that the half-life of a substance is the length of time required for the substance to decay to half the amount. So if it started off at 10 grams, what is the new amount? 5. Okay, so I'm going to divide by 10, so I get 0.5 equals e to the power negative that's supposed to be 0.4, sorry. It's in my calculator, right? So now I'm going to ln both sides. Why am I lning? Because there's a base e, yes? So ln of 0.5 equals negative 0.04462 blah, blah, blah t. So again, I have my alpha A in there, right? Use the alpha A. So T is going to be approximately 15.5314, and that's going to be years. Why? Because it said it was years to be in the question.